Hello friends, welcome to VK Lectures. In this lecture we are discussing the probability distribution part 2, where we will be discussing about binomial distribution, Poisson distribution, Gaussian and the normal distribution. Binomial distribution. So this type of distribution is used when there are a finite number of trials. The trials are finite and applied when there are two possible outcomes. Uh, the favorable and unfavorable. This is in general for every distribution. There will be a favorable outcome and unfavorable outcome. Now the favorable outcome is given by the favorable. Favorable is given by the letter P, while unfavorable is given by the letter Q. Okay. Now, so this is the favorable, and we know that P plus Q, the unfavorable plus the favorable probability, should be equal to 1. Okay. Now, if I take, for example, coin, I am tossing a coin, so head or tail. If getting a head is my probability P is getting head. Probability P getting head means it is my favorable probability. Then Q will be equal to unfavorable, which will be equal to T. And what is the probability of getting head? That is equal to 1 by 2. Getting a T is 1 by 2. So P plus Q, 1 by 2 plus 1 by 2, that's equal to 1. Similarly, if I throw a dice, throwing a dice, the probabilities are P. For example, favorable probability is getting 1. Getting 1 is my favorable probability. So what is the probability of getting 1? That's equal to 1 by 6. And Q, not 1, probability of getting not 1, other than 1 anything is possible, that's equal to 1 minus the P, that's equal to 5 by 6, because all other numbers are there. So what is the dice? When you throw a dice, the sample space is 1, either you get 1, 2, 3, 4, 5 or 6. So getting a 1 is my favorable probability, that is 1 by 6. Unfavorable, that is Q, not 1. So it can be either 2, 3, 4, 5 or 6. So that is 5 by 6. Now, what is the binomial distribution says? So the binomial distribution says for the favorable probability P and the unfavorable probability Q, we can write the probability of probability of getting r times in favor of our favorable outcome out of the n trial. So Pn of r represent probability of getting r times in favor of the total number of outcome is n is equal to NCR combination P power r q power n minus r. So this is the binomial distribution formula. Pn of r equal to NCR P power r q to the power n minus r, where P is the favorable probability, Q is the unfavorable probability. You can write here the statement: the probability of getting r times in favor out of n trials. This is the meaning. Good example is, I am throwing a coin or tossing a coin 5 times and I want to get 3 heads. So I will write probability of getting 3 heads out of 5 trials. So P 5 of 3. Okay. Substitute all the values. N is equal to 5, R is equal to 3, P is equal to, since it is a coin, 1 by 2, Q is again 1 by 2. So this is just an example. So let's start. So Pn of R, which is probability of getting r times in favor out of the n trials, is equal to NCR P power r q power n minus r, where n is the total number of trials here, where n is the total number of trials, while the r is the number of favorable number of favorable, then P the favorable probability. And Q is unfavorable. Okay, so these are the parameters required here: N, R, P and Q. Now let us do a problem, that is Q. Okay, let's start with the question. A coin is tossed for 10 times. So 10 times the coin is tossed. Find the probability of getting getting 5 times head. So this is the question, and we can start with the Pn of r, that's equal to P 10 times, n is a total number, and how much head I have to get? 5 times. So that's equal to NCR. So 10 C R is 5, P power R, P power P probability is 1 by 2 to the power R, and Q is again 1 by 2 to the power 10 minus 5, that is again 5. So 10C5 means 10 factorial by 5 factorial into 10 minus 5 factorial, that is 5 factorial, into 1 by 2 to the power 5 into 1 by 2 to the power 5. So this is the probability. So this is the probability of getting R times in favor of n times trial. So that is P n is 10 of 5. Now the question number 2. Here again a coin is tossed. A coin is tossed for 3 times. Tossed for 3 times. And remember that a coin is tossed for 3 times, or 3 coins are tossed simultaneously. Both have the same sample space. Okay. So a coin tossed for 3 times, and find the probability of getting. Find the probability of getting. Find the probability of getting A 0 head, 0 heads, okay, 0 heads. Then B 1 head, and C 3 heads. So the first one, P, how many trials? 3. Total number of trials is 3. 0 heads, so 0. That's equal to n, that is 3C0. P power probability 0. Q power 0. So that's equal to 3C0 means 3 factorial by 3 factorial into 1 by 2 to the power, sorry, this is 3 minus 0. So 1 by 2 to the power 0 into 1 by 2 to the power 3. So that's equal to 1 by 2 to the power 3, because 3 factorial by 3 factorial is 1, and 1 by 2 to the power 0 is again 1. So that's equal to 1 by 8. B 1 head, so P 3 of 1, so that's equal to 3C1, 1 by 2 to the power Q to the power 1, and P to the power 1, and Q to the power 3 minus 1, that is 2. So that's equal to 3 factorial by 1 factorial into 3 minus 1 factorial, that is 2 factorial, into 1 by 2 into 1 by 4, that is 1 by 8. So 3, that is 3 by 8. So again C, P 3 of 3 heads. So 3C3, 1 by 2 to the power 3, and Q to the power, that is 1 by 2 to the power 3 minus 3, that is 0. So 3C3 is 1, 1 by 2, that is 1 by 8. Now, a few things we need to remember from binomial distributions. If you represent the Pn of n, small letter n, instead of r we are just writing n, is equal to NCn p power n q power n minus small n. Then an operator, here is an operator that's given by the p dou by dou p. The operator p dou by dou p gives the value n, number of favorable outcomes. Then that is one idea. The second one is the mean of the value. Mean of the favorable outcomes, or you represent it by value x or mu is equal to n, the average of the favorable outcome. N is given by mu is equal to the probability, that means the total favorable probability times n, total number of favorable outcomes, where n is total number of trials, and p is favorable probability. Now coming to the next term, that is third one, the average of x square or average of n square. So average of x square or the average of n squared is equal to np plus np squared plus np squared minus np square. And what is this np? Np is nothing but pn or mu, so that's equal to np plus, so the average of mu square, or this is n squared minus np square. And again this and what is this? This is n squared. And from here what you are going to get is n squared minus average of n squared is equal to np minus np squared. That's equal to np into 1 minus p, and 1 minus p is nothing but q, so that is npq. And what about this? This is nothing but the variance, sigma squared. This is variance, that is sigma squared. So sigma squared will be equal to npq, and thus n is equal to, or sigma is equal to root of npq. So that is it. A few things more you can remember, that is p plus q whole to the power n. So p plus q whole to the power n is expanding. On expanding, what we will get? Sum over ncr p power r q power n minus r, and Mu we have already discussed, the mean value, which is equal to Pn, and the standard deviation, this is sigma, which is standard deviation. Standard deviation. So far what we have learned is the binomial distribution. Binomial distribution, and we know p plus q whole to the power n is given by sum over r ncr p power r q power n minus r. So this is the binomial expansion, and you also know that n is finite, so there is a finite value of n. So this is for binomial distribution. Now when n tends to infinity, that means n is going to infinity, you have uncountable variables. Uncountable variables. Okay, variable values. For example, x equal to from all the real numbers between 2 and 3. So this is where n tends to infinity. Now when n tends to infinity, there are two cases when Poisson distribution and Gaussian distribution. So this is where we distinguish the distributions. So binomial distribution, when n tends to infinity, there are two cases where n is infinity. So for Poisson distribution also, this is n is infinity, and for Gaussian also n is infinity. And here for Poisson distribution, p, the favorable probability, will be nearly equal to 0, and here also p is nearly equal to 0. This is a small mistake, is very small. We cannot consider it as 0, but here in the Poisson distribution it is nearly equal to 0. So in the limits where n tends to infinity and p tends to 0, this is the Poisson distribution, and the limits for n tends to infinity and p nearly or tending to 0, or we say very small value, this is the Gaussian distribution. This is Gaussian distribution, and this is Poisson distribution. Coming to the Poisson distribution, we have the limit the n, the number of trial is tending to infinity, and the favorable probability is tending to 0. We have b of r, which is given by sum over ncr p power r q power n minus r. Okay, so the mu, the expectation value or average value mu is given by mu is equal to n times p. Similarly, we can write from here p is equal to mu by total number of trials, the average, and q is equal to 1 minus p. On substituting all these values, we will get the p of r. P of r represent probability of getting r times in favor in infinite trials. So in infinite trials, how many? Infinite means very large, so that is the meaning. Infinite trials is given by p of r is equal to mu to the power r by r factorial into e to the power minus mu, where mu is the expectation or the average value. Mu is equal to n times the favorable probability p. Here we have one question. The question is 10% of the phones manufactured is found to be defective. Find the probability that in a sample of 10 phones chosen random exactly 2 phones are defective. So here the answer goes like this. Here the total number of outcomes is n is equal to 10. The probability, favorable probability, is we need defective one, so 10%. So 10% is nothing but 1 by 10. Then the average mu is equal to n times p, that is n is 10, p is 1 by 10, that's equal to 1. Then p of r equal to mu power r by r factorial into e to the power minus mu. So let's substitute all the value. Mu is 1 to the power r is, we need 2, so p of 2. So p of 2 equal to 1 divided by 2 factorial into e to the power minus 1. So 1 by 2e. So this is the probability of getting 2 phones which are defective out of the 10. Here is a practice question from Poisson distribution. If the probability of unfavorable reaction from certain injection is 0.001. What is the probability that out of 2000 individuals, two people get the reaction? Get the reaction. So here the unfavorable, or the probability that we need unfavorable is our reaction, or the probability P. So 0.001, and the total number of these people are 200 outcomes. Out of these 200 trials or 200 people, we need 2 people to get it, 2 people to have. So mu is equal to NP, so that's equal to 200, N is 2000 into P is 0.001, that's equal to 2. Now P of R, probability of R, that is equal to probability of 2, equal to mu to the power R by R factorial into e to the power minus b. So that's equal to mu is 2 to the power 2 R is 2 by R factorial, that is 2 factorial, into e to the power minus 2. So 2 to the power 4 by 2 factorial, that is 2 e to the power minus 2, that's 2 divided by e squared. Now this is the one part of the question. Now the second part is what is the probability that more than 2 people get the reaction? So same terms all remains same. So we need P for R greater than 2, more than 2. So R should be greater than 2, which means P of 3 plus P of 4 plus P of 5, etc. up to how many? 2000 people. So P of 2000. So when you add all this, you get more than 2 people who getting the reaction. So this is just like P at least 2. So we can do this. P of at least 2 is equal to 1 minus P of 0 plus P of 1 plus P of 2. So it's actually at least 3, not 2, because minimum 3 should be there. More than 2 means minimum 3. So 1 minus, we need to find P of 0 plus P of 2, P of 1 plus P of 2. 1 minus this one should be in bracket. So that gives us 1 minus P of 0 means, put P of 0 here, so mu to the power, mu means 2 2 to the power 0 divided by 2 factorial, sorry, that is 0 factorial, r factorial, 2 to the power 0 e to the power minus 2 plus p of 1 r equal to 1. So 2 to the power 1 divided by 1 factorial into e to the power minus 2 plus p of 2 is 2 to the power 2 divided by 2 factorial plus e to the power minus 2. That's equal to 1 minus 2 to the power 0. So this is 1 by e square plus 2 to the power 1. So that is 2 by e square plus that is 4 by 2 2, so 2 divided by e square. So that's equal to 1 minus 1 plus 2 3, 3 plus 2 5, so 1 minus 5 by e square. So this is where minimum of 3 or more than 2 people get this reaction. Coming to the Gaussian distribution. Gaussian distribution, we have x, the continuous random variable, then if the x is the continuous random variable, then the corresponding probability that is f of x, this is the corresponding probability f of x, is given by 1 by root of 2 pi into 1 by sigma into e to the power minus of x minus mu squared divided by 2 sigma square. So this is the corresponding probability for x for the continuous variable, where sigma is the standard deviation and mu is the mean value. The maximum probability so maximum probability is when this is equal to, this entire term becomes 0, and thus the maximum probability becomes 1 by root of 2 pi into 1 by sigma. So this is the maximum probability it can have, and expectation value of the x or the mean is the mu, and expectation of x square is 2 sigma square, the denominator. What is this? 2 sigma squared divided by 4 plus mu square. 2 sigma square, that is whatever is in the denominator, by 4 plus mu squared. So the Gaussian distribution is somewhat like this. So this is the x equal to mu here. So this is mu is the average. This is called the center of the Gaussian. Center of the Gaussian. When one more thing, when the standard deviation sigma is equal to 1, then the Gaussian distribution is called Gaussian is called normal distribution. So coming to what, so once again let us going back to the Poisson distribution. From Poisson distribution, what we know is n is tending to infinity and the probability, favorable probability, is tending to 0. Then the mu, which is equal to n times p, is a finite value. Then the favorable probability or the favorable value, p of r, probability of getting r times in favor of infinite trials, p of r is equal to mu power r by r factorial into e to the power minus mu. Now mu is equal to np, so that's the mean. Then here we need to understand that p is nearly equal to 0 and q is equal to 1. When p is equal to 0, q equal to 1, because p plus q should be equal to 1. So sigma standard deviation, or the sigma, is given by root of npq. Now q is equal to 1, so we can write root of np. And what is np? That's equal to mu. So root of mu is sigma, or sigma square, which is the variance, is equal to mu. So for this Poisson distribution, is sigma square is variance, and that is equal to the average value mu. So one thing that we have to again remember from this distribution is sigma, which is standard deviation, cannot be added. While the variance, which is the square of the standard deviation, can be added. That means if there are two variables, you can add these two. Sigma can be added, algebraic addition. Okay. The last concept from this session, that is random walk. Problems based on random walk. So random walk problems. Now a person from point A, so this is the point A, travels and reaches a point B. Okay, so this is the point A, this is somewhere the point B, it's connected. Right, now this is from A to B, there are m steps. Okay, m steps, but this person from A to B is taking n steps. Okay, he is taking more number of steps where capital N is greater than m. So originally there are only m step, but he is taking capital N number of steps to reach, because he is taking one step forward and the next step he may go backwards. Only then this would happen. He is in one-dimensional motion, please remember that also. So if he is taking one step forward and one step backward and then two step forward, so moving like this, forward and backward, so that is why he is taking more number of steps. Okay, now we have to understand, and steps, each step has particular size, it does not change. Step means just one step for everything. Okay, so it is not the property of the size of or the length of the step. No, in general he is taking more number of steps. So n is the total number of steps, so n steps he is taking. So out of this n steps we can classify the n steps into two different categories, that is forward steps. Forward steps means towards B, forward in the positive direction, so that is positive direction. This is the negative direction towards A. Okay, so in the positive direction he is taking n1 number of steps. Okay, and in the negative direction or backward direction, backward negative, it is towards A, and towards A he is taking n2 steps. And if the person reaches B, if the person reaches B, then n1 should be greater than n2. Only then he will reach the point B. If n1 equal to n2, what happens? He will be on the same place. Number of forward step equal to number of backward step. If he starts from here, he will reach the same point if the number of forward steps is equal to number of backward steps. So if n1 equal to n2, he will be on the same place. Okay, and if he reaches this B, there is one more thing. The net steps n will be equal to n1 plus n2, I mean the total number of steps, and net steps n net, that is given by m is equal to n1 minus n2. Okay, so let us write down what are the things here. So total number of steps, so total number of steps is equal to capital N, that is capital N is equal to forward steps plus the backward steps. The effective steps or the net steps means there should be only m steps. Okay, so net steps, that means we assume that he reaches the point B. Okay, assuming that he reaches the point B, net steps equal to m, which is given by n1 minus n2. These are two equations, 1 and 2. You can add 1 plus 2, that gives n plus m equal to 2n1, which gives n1, number of forward steps, is equal to n plus m by 2, and 1 minus 2 gives 1 minus 2 gives n minus m, that is equal to 2n2, that implies n2, that means number of backward steps is equal to n minus m by 2. So this is two equations that we need: number of forward steps, number of backward steps. Backward steps, number of forward steps is given by positive, number of backward steps the negative. Now according to the binomial theorem, we have binomial distribution. Bn of r, this is as Pn of r itself, that's equal to NCR P power r Q power n minus r, as capital letter n minus r. So we already know that is forward steps. If you have n steps, out of these n steps there are forward and backward. So forward steps are n1, backward step is n2, and probability of taking a forward step p, if we assume that p is what we need, is half. Similarly, he will take the backward step is also half. There is no choice. Other choices are not there. So forward steps. So this must be q. So q equal to half and p equal to half. So favorable is half. Only then we can go to other end. If we want to travel from A to B, we need forward steps. Okay, so from this the idea is the concept is regarding the probability of reaching the destination which is m steps away. So this is m steps away by taking capital N steps. So this is the question. What is the probability of reaching the destination which is m step away by taking n steps? So that's given by Pn of m. So probability of reaching the destination which is m step away by taking capital N steps, that's equal to n factorial by n plus m by 2 factorial into n minus m by 2 factorial into 1 by 2 whole to the power n. So this is the probability of reaching the destination which is m step away by taking capital N steps. And there is another note. If the person reaches the starting point, what is the starting point here? Starting point A. That means n1 number of forward steps equal to the number of backward steps, which means that m is equal to 0. That means the effective steps n1 minus n2. This is that means he is not reaching the point. If not reaching the point means effective steps will be equal to 0, which means n1 minus n2. So if that is the case, what is the probability will be p n of 0, that will be equal to n factorial by n by 2 factorial into n by 2 factorial into 1 by 2 whole to the power n. This is also the maximum probability. That means the maximum probability is that he reaches the same point, because the probability of taking the forward steps and the backward steps are same. and if P, probability of taking the forward steps, is not equal to probability of taking the Q, then we must go with this formula, Bn of R equal to NCR P power R Q power N minus R. So this will be the probability. Here's a question. A random walker takes a step with equal probability This statement means that the P and Q are same probability to, this time it is left or right, it is not backward or forward, it is left or right. What is the probability that the walker returns to the starting point after taking 4 steps. So after 4 steps, what is the probability? So n, the total number of steps, equal to 4. So n is equal to 4, and m is equal to 0. So P, probability, equal to n factorial divided by n by 2 factorial into n by 2 factorial into 1 by 2 whole to the power n. That's equal to 4 factorial by 2 factorial into 2 factorial by 1 by 2 whole to the power 4. So this is 1 into 2 into 3 into 4, 1 into 2, 1 into 2, so 1 by 16. So 1 2 get cancelled, 2 and 4 goes for 2, that is 6 by 16, that is 3 by 8. So the probability of reaching the destination is 3 times out of 8.